Hello everyone and welcome to this brand new video. Today I'll be talking on superposition theorem and I'm going to explain how we can use it in order to analyze and simplify complex electrical circuits. So firstly, superposition theorem is a method used to analyze linear circuits with two or more independent sources, and we do that by eliminating one circuit or substituting one circuit, analyze the circuit with one source, then eliminating the other source and analyze the circuit with the other source only. Then after that, we add the contributions of each source. So for instance, this is an example I used to illustrate this very easily. Let's want to calculate the current that flows through this resistor. What we are going to do is we are going to substitute V1. We calculate the current flowing through R1 based on the voltage source V2. Then later on, we substitute the voltage source V2 and calculate the current flowing through R1 based on V1. After that, we are going to take the algebraic sum of both currents to have the total current that flows through the resistor R1. So basically, that's the theory about superposition theorem. Like I earlier on said, superposition theorem states that in any linear circuit containing two or more independent sources, the voltage across or current through any element is the algebraic sum of the voltages or currents produced by each independent source acting alone, with all other independent sources turned off. And for a very important note, it's good to note that superposition theorem only applies to linear circuits. It does not apply to non-linear circuits. And again, the steps in order for us to calculate, to apply superposition theorem, the first is we use one source at a time. If we have three independent sources, you substitute two, you analyze the circuit with one source, then you substitute the other and analyze with one source until you analyze all three independent sources. So one source at a time, turn off other sources, find individual contribution, then add contributions algebraically to have the final answer. How to turn off sources? When turning off independent sources, for voltage source, we replace the voltage source with a short circuit. So when you want to replace a voltage source, you take out the voltage source and you replace it with the short circuit. For current sources, we replace current source with an open circuit. So we just take out the current source and leave it open. And it's also important to note that dependent sources are never turned off. We only do this with independent sources. And for you to understand, independent sources are sources that does not depend on any other component in the circuit to be able to provide voltage or current, whereas a dependent source, it depends on another voltage source or another current source in order to be able to provide voltage or current in the circuit. So when you see this round stuff, this always represents independent source. When you see dependent source, it's going to be like a diamond-like shape. Let's get into it. So now let us find the current flowing through resistor R3 using superposition theorem. So have all of our data. E1 is given, E2 is given. All the resistances are given. So let's get into it. The first thing we need to list the steps in order we need to follow. The first step, identify all independent sources. We have E1 and we have E2. E1 12 volts, E2 6 volts. Next step, choose one source to keep active. We are going to start by keeping E1 active and eliminating and substituting E2. Well, keep one E1, substitute the other. We are going to substitute E2. Calculate the voltage or current of interest. Here we need to calculate the current of interest. Then repeat step 2 to 4 for every other source. Add all contributions algebraically. Okay, it is also important to remember that superposition theorem, this method of substituting only works when we're calculating current and voltages. It doesn't apply when we are calculating power, right? So you cannot substitute one source, calculate the voltage, the current, then you calculate the power, you do with the other source, you calculate the power, then you add all the powers together, that is not going to be right. That is only right when we apply it to voltages and currents. Okay, so let's get up with solving our question. So step 1, we leave E1 active and E2 is turned off. As you can see, E2 we remove and just put a short circuit. So firstly, in order to calculate the current through R3, what we are going to do is we are going to calculate the total current that flows into this circuit. So we are going to take the equivalent resistance of this entire circuit, calculate the total current. After that, we are going to, after having a total current flowing into this circuit, we are going to use current divider to be able to calculate the current that flows through resistor R3. If you haven't studied current divider and voltage divider, there's a video on my page, you can check that out. So let's go. So firstly, you will notice that we have resistor R3 and R2 are in parallel since this is short circuited. R3 and R2 are in parallel. So what are we going to do? We are going to take 6 multiplied by 4 divided by 6 plus 4. The equivalent resistance between these two is going to be 2.4 ohms. And after calculating the equivalent resistance between these two resistors, we are going to realize that that equivalent resistance is going to be in series with R1. So we are going to have R2 parallel R3, so it is supposed to be R3 in series with R1. So R total is going to be equal to 2.4 plus 2 equal to 4.4 ohms. That is the total resistance of this entire circuit. So now we need to calculate the total current. The total current is going to be this voltage divided by the total resistance, which is going to be equal to 12 divided by 4.4. We are going to have a total current of 2.72 amperes. That is our total current. Now to calculate our first current flowing through R3, which is going to be I3 prime, we are going to denote it at I3 prime. We are going to calculate using current divider, which is going to be equal to the total current multiplied by R2 divided by R2 plus R3. People who know voltage divider understand this formula already. If you do not understand that, there is a video on my page, you can check that out to better understand. And we substitute the values, we are going to have a current of 1.08 amperes. That is the value of I3 prime. Now let's go to the step 2. Step 2 now, we need to keep E2 active and then turn off E1. So in this case, we are going to realize that R1 and R3 are in parallel because we are going to follow the same steps, calculate the total current in the circuit, then the current flowing through R3. So we are going to calculate R3 and R1 are in parallel. We are going to calculate the equivalent resistance. 2 multiplied by 6 divided by 2 plus 6, 1.5 ohms. And we are going to realize that this equivalent resistance between both of them is in series with this resistor R2. So we are going to have the R total resistance going to be equal to 4 plus 1.5. Our total resistance of this entire circuit is 5.5 ohms. Then we are going to calculate the total current. The total current is going to be the total resistance, which is E2 divided by R total is going to be equal to 6 divided by 5.5. We're going to have 1.09 amperes. Now again, to calculate the current that flows through R3, in this case, we're going to denote it as I3 prime prime. We're going to use current divider to calculate it. Same formula, the total current R1 multiplied by R1 plus R3. To substitute the values, and we're going to have 0.273 amperes. And that is the value for I3 prime prime. Now, in order for us to have the total current of I3, we need to take the algebraic sum of both currents, like the algebraic sum of both contributions, the contribution of voltage source E1 and the contribution of voltage source E2. And when we do that, we are going to have I3 is equal to I3 prime plus I3 prime prime is going to be equal to 1.08.0.273. We we're going to have a total of 1.353 amperes, and that is going to be the total current flowing through the resistor R3. Some key points to remember about superposition theorem: it only applies to linear circuits. We analyze one dependent source at a time. We turn off sources. We turn off voltage source by short circuit, and we turn off current source by an open circuit. Dependent sources stay on. This is like a symbol of a dependent voltage source. Dependent sources, they stay on. We find the individual contribution of each source. Then we take the algebraic sum of all contributions, and then we have our answer. And it's also important to remember that superposition only applies to voltage and current and not power. And that is the end of this video. Please, if you found this video interesting and educating, please like, subscribe, and share. And see you in the next part. Have a blessed day.